Hello, my name is Steve Bowler, and in this video we're going to be taking a look at Border Gateway Protocol. Specifically, within BGP, we're going to be taking a closer look at IBGP and BGP Authentication. I'm also going to explain to you what you would use IBGP for. And IBGP is most commonly used when you are connected to the internet via two different routers or exit points out of your autonomous system. IBGP allows you to manipulate traffic exiting your autonomous system using BGP attributes such as local preference. And it should also be known that all IBGP routers must peer to each other, and if this is not the case, then routing loops and black holes can occur. And there are ways to offset the IBGP full mesh rule, where all IBGP neighbors should be connected to each other. And this can be done through means or ways such as using route reflectors or confederations. So there's a couple of differences right off the bat you can see between IBGP and internal BGP and external BGP. External BGP, you can use the AS path attribute to manipulate. However, with IBGP, what we're going to find out is we're within the same autonomous system number. In this case, we have router 1 and router 3 and autonomous system 100. So we cannot manipulate, and BGP has no way of using the autonomous system path number as a means to manipulate any of its configuration and how it knows how to get around the network. So that is why we're going to see that all IBGP routers must have a connection to all other IBGP routers unless you're going to have major issues. So one of the first things we're going to find out within IBGP is that you don't have to be directly connected to a router like we see in external BGP. So in external BGP, our lab, we had R1 and R2 connected to each other via the 12 network, and they peered to each other using their neighbor addresses. So for instance, router 1 had the neighbor address of 12.12.12.2, and router 2 had the neighbor address of 12.12.12.1. Now, I'm not saying you cannot change this within external BGP, because you can use what's called eBGP multi-hop to do this. However, the default rules for external BGP is that you peer over the directly connected interface. What we're going to see though is with IBGP, this is not the case. And what we're going to do is we're going to peer using our loopback interfaces. And that is the most commonly used method in a lot of networks today. And if you think about it, it makes sense, because if you peer directly with the directly connected IP address, well, what happens if that link goes down? Well, then your BGP neighbor relationship is going to go down. However, if you peer using a loopback, well, the loopbacks will never go down. And so if you have multiple ways to reach the router, then you kind of safeguard your connection when you peer to a loopback, because if you have 3 ways to get to a router and you peer to a loopback, when one of the ways goes down, or one of the interfaces, then that router can still be reachable via the 2 other links. Okay, so that's just a brief overview of some of the differences between internal BGP and external BGP. What I'm going to show you too is that we must have reachability inside of our IGP, our interior gateway protocol, for our IBGP neighbor relationship to form. So what I'm going to do also in this lab is I'm going to set up some trace options. And if you don't know what trace options are, you should watch my trace options lab, where I give you a solid foundation on trace options. We're going to use trace options to see exactly what's going on with the BGP neighbor relationship process. And then after I form the IBGP neighbor relationship, we're going to show you BGP authentication, and then we're going to be done with the lab. So just to give you a brief overview again, this network, we have router 1, router 2, and router 3. We are using logical tunnels, and these routers are all logical systems. So again, logical systems, if you haven't seen that lab, logical systems are created on one physical Juniper router, and then we combined our logical systems together using logical tunnel interfaces. In this lab, all logical tunnels are using the format LT-120.XX. So for instance, router 1's tunnel interface to router 2 is LT-120.12. So the connection between R2 to R1 is logical tunnel 21. The connection between router 2 to router 3 is logical tunnel 23. And the connection between router 3 to router 2 is logical tunnel 32. Router 3 also has a loopback 0.3 interface with the 3 network and the 33 network on it, and router 1 has the loopback 0.1 interface with the 1 network and the 11 network on it. So again, if you're not familiar with logical systems, I would suggest watching my logical systems video that explains the logical tunnel interfaces. All of these interfaces and this whole network is made up of OSPF area 0. So the first thing that I'm going to do is I'm going to set up all the connections real quick. So let's go ahead and get started. We're going to do this on the fly, so we'll do set logical systems R1. Interfaces LT-120. The unit is going to be 12. Encapsulation is, actually let's do this. We'll put in the IP address first. Family INET address 12.12.12.1/24. So we're going to make our connection first. We're building our connection to router 2. Peer unit 21, and the encapsulation is going to be Ethernet. So if you're not familiar with what I'm doing or what these commands are, again, watch my logical systems lab, then you'll know exactly what I'm doing. We're going to use the connection from router 2 to router 1 is going to be using unit 21, again LT-120.21. The IP address is 12.12.12.2, and that's /24. The peer unit is going to be 12, and the encapsulation is going to be Ethernet. Now let's get the connection from router 2 to router 3. The IP address on this connection is going to be 23.23.23.2//24. Peer unit is going to be 32, and again the encapsulation is going to be Ethernet. So router 2 should be done at this point. Now we're going to make our logical system R3. First going to give it the IP address of the .3. Then we're going to bind it to R2 using the peer unit of 23. Then our last command is going to be our encapsulation, where we set to Ethernet. While we're on R3, let's go ahead and create our loopback interface. So loopback 0 unit 3. family inet with the address of 3.3.3.3/24. Also, we have the 33 network. Let's set up router 1s as well. So R1 interface is going to be loopback 0 unit 1 family inet address 1.1.1.1/24 and then 11.11.11.11/24. Okay, so now what we're going to do to verify this, we're going to log in to router 2 with the command set CLI logical system R2. This is going to bring us to router 2's command prompt. In operational mode, let's go ahead and get in it. Let's stay in operational mode. If we do a show route from router 2's perspective, we have connection to the 12 network and the 23 network. So let's go ahead and ping router 1 from router 2, so 12.12.12.1, and you can see we have reachability. Also, let's go ahead and ping the router 3, so 23.23.23.3, and we have reachability there as well. So at this point, we have built our connections in the network diagram. The next thing we're going to do is we're just going to enable OSPF area 0 on all interfaces. And if you're not familiar with how to set up OSPF, then I would suggest watching my OSPF labs. However, I'm going to run through this real quick and show you exactly how to do this. So from router 1's point of view, let's do this. Under R1, we'll go under configuration mode. We're going to set up OSPF using the command set protocols OSPF, then our area type. Now we can specify our area using the following format, or we can just put in area 0. That's what we're going to do. Then we're going to advertise our interfaces into OSPF area 0, so interface LT120.12 and also interface loopback 0.1. That should be it for router 1. Router 2, we're going to do the command set protocols OSPF area 0. Interface we're going to advertise is 120.21. We're also going to put in, and then again, that was our connection to router 1, and then also 23, that's our connection to router 3. So very easy to set up OSPF if you've never done it before. Also, I advise you to watch my OSPF labs. They'll give you a lot of helpful information and insight on how to do that. Oops, sorry. Let's go to router 3, set CLI logical system R3, and now from R3 we're going to do the command set protocols OSPF area 0, interface LT120.32. Also, we're going to advertise our loopback, so interface loopback is 0.3. And to verify our OSPF neighbor adjacencies, you can just on router 3 do a show route. Actually, let's do this. Let's log in to set CLI logical system R is show OSPF neighbor, and we can see that we have neighbor relationship with R1 and R3. And we can see from router 1's point of view, we can see router 1 is learning the 3 network from router 3, and it also is learning the 23 network via OSPF. So both of these networks are being learned via OSPF. Also, I'm sorry, the 33 network as well. And this is telling us that we have reachability. So OSPF is our IGP in this lab. We have to be very careful when we're setting up IBGP in that it doesn't have to be a directly connected neighbor relationship. And what we're going to see in this lab is that we're going to peer using our loopbacks. So in order to do this, we have to make sure that we have reachability to the loopbacks. If we don't, then the BGP updates, the IBGP updates, will not be successful, and our BGP neighbor relationship will not form. So it's very important that you understand that you have full reachability, in this case from router 1's loopback to router 3's loopback. If we don't have that, then we will not be successful. We can test this. I did a ping. Let's source the ping. We'll do a ping 3.3.3. We'll source it from 1.1.1.1 on R1. Let's do a rapid count of 100 or 1,000. And you can see we have reachability. So let's go ahead and get started with our IBGP configuration. Now that we have our interfaces all built and our interior gateway protocol, or IGP, built as well. What we're going to see is that the configuration between external BGP and internal BGP is pretty similar. There's only a couple main differences that I'm going to show you and explain to you that need to occur. On R1, let's go ahead and set up internal BGP, our connection to router 3. So the first thing that we're going to do is we're going to set the routing options and use the command. If you're not familiar with this, if you haven't seen my BGP video lab 1, I'm going to explain this to you. What we're going to do first is set up our autonomous system on R1. Again, router 1 and router 3 are in both in autonomous system 100. This is an internal BGP connection. External BGP, obviously, you would have 2 different autonomous systems connected to each other. So internal BGP is where you have the same autonomous system between 2 routers. We're going to set up the autonomous system on R1 using the command set routing options autonomous system and then our autonomous system number, which is 100. The next thing we're going to do is we're going to go under edit protocols BGP, and we're going to set up the group option. So we're going to define a peer group. In this case, our group is going to be called IBGP. And under this group named IBGP is where we're going to have some of our configuration options set towards router 3. In this case, we're going to have the option, we'll do set. We can see in our list we have the type of peer, In this configuration we're using internal, so we're going to set the type to internal for internal BGP. We're also going to use the command set, and what we can see is we're going to use the set peer autonomous system. So this is the autonomous system that we're peering with. In this case, R3 is also in autonomous system 100. And then our last command that I'm going to show you at this point is the neighbor statement. So we're going to do the command set neighbor, and then 3.3.3.3. And then the last thing I'm going to do is on R1 is set up some trace options so we can look at some of the output on R1 and see exactly what's going on with our neighbor relationship to R3. Also, if you don't know about trace options, go ahead and you can watch my trace options lab, which I explain how to set up trace options. In this case, we'll just do set trace options, and we'll call our file IBGP. Or we'll do this. We'll just create the trace options file. We'll call it R3. Our R1, let's just do this R1 to R3. So again, our file name is R1 underscore R3. Within the trace options with BGP, we're going to set the flag to all. So we're going to be capturing all BGP events. Okay, so on R1, if we recap what we did, let's just do a show configuration. We can see that we have the BGP protocol for group. We created the group IBGP. We specified the type of internal, again IBGP. We have the peer autonomous system for router 3 is in autonomous system 100. We have the neighbor address. In this case, again, we are peering with our loopbacks. So router 3, we're going to be peering using the 3.3.3.3 IP address. Also, we went under the routing options and we specified the local autonomous system for our router as 100. So now let's go under router 3 and let's do the configuration on the IBGP configuration on R3. First thing I like to do is go under and set the autonomous system, the local autonomous system for the router. In this case, we do the command set routing options autonomous system, and then specify our autonomous system, which is 100. Then we're also going to do the command. We'll go and create our BGP group, where we're going to specify our statements towards router 1. So we'll do the command edit protocols of BGP, and then group, and then our group name, which is, we'll just call it IBGP. So we're going to set the type to internal. We're also going to set the peer autonomous system to 100. And our last statement right now is we're going to set the neighbor statement to 1.1.1.1. So router 3 is going to peer to router 1 using the neighbor address of 1.1.1.1. Router 1 is going to peer to router 3 using router 3's 3.3.3.3. So from router 1, if I do a show BGP summary, we can see that we are experiencing our first problem, and that is that if you know anything about BGP, then you know that the state being active is not a good thing. And that is what we are getting at right now. We're not completing the BGP connection, and our peer, we're not forming an established neighbor adjacency, our relationship. Let's go ahead from router 1's point of view. We created a trace options file. Let's go ahead and try to look at this file. And this file was R1 to R3. So to view that, let's just do show log R1 to R3 and see if we can see exactly what's going on. And with this trace option, what we can see is that we are sending updates locally from router 1's point of view using the 12.12.12.1 IP address towards router 3, which is correct. This is our neighbor statement that we put in. So we're trying to peer with router 3. Let's go on router 3 and let's do this. Let's go and set trace options on router 3 as well. So on router 3 we'll do set trace options R3 to R1. Also do set trace options flag all. So what I'm trying to show you is that one of the reasons why the main reason why the BGP neighbor relationship is not able to form is because we are not properly sourcing our internal BGP updates. In this case, router 1 is the source of router 1's BGP updates is the 12.12.12.1, and router 3, if we look at our network diagram, router 3 is expecting these BGP updates on the 1.1.1.1 IP address. Likewise, if we were to go look at router 3, if I do a show log R3 to R1, what we're going to see is that router 3, with the BGP send in our trace option file, we can see that router 3 is sending updates on the 23.23.23.3 IP address to router 1, which is 1.1.1.1. So again, the peer statement is correct. However, our local source for our BGP updates is our exit interface towards the neighboring router. So right now it appears as though the source of our updates is configured incorrectly. So what we're going to have to do to fix this is we're going to have to source our updates. We're going to have to configure both R1 and R3 to source their updates from their loopback. And the way you do this is from router 1's point of view. We're going to go under Edit Protocols BGP, and then we're going to go under our group that we created named IBGP. We're going to use the statement called set local address. And if we look at this before we enter, this is the address of the local end of the BGP session. So we'll do the command set local address, then we'll set it to 1.1.1.1. And this command is the equivalent to using, if you're familiar with setting up IBGP on Cisco IOS, this is similar to the Cisco IOS command of update source, of pretty much like you're putting in the command update source loopback 0 for your neighbor. So same concept, same thing is going on right here. So we're going to set our local address for our BGP updates to 1.1.1.1. Now let's go under router 3 and do the same thing. Edit protocols group, edit protocols BGP group IBGP, and then under the BGP group we're going to set the local address to 3.3.3.3. Again, we want to send these updates from our loopback 0 interface. So we're going to go ahead and commit and quit. And on R1, if I do a show log R1 to R3, what we are seeing now is that we are sending updates on from the 1 network to the neighbor, which is the 3. So now if I do a show BGP summary from router 1's point of view, you can see now that we have an established neighbor adjacency. Also, let's just do the show. If you want to see the established, if you do show BGP neighbor, we can see that we have our peer, which is R3, the local IP address, and the state is now established. So this is a great command, show BGP neighbor. It gives you a lot of information on your peer. And if we look at our log, let's see if we can see this again. Before, when we weren't getting our IBGP neighbor relationship established, we were sending updates out of the 12.12.12.1 towards the 3 network. So we were not able to establish a neighbor adjacency doing so. And that is because router 3 was trying to peer with router 1 using the 1.1.1.1 IP address, and it was seeing these updates on the 12.12.12.1. So obviously the IBGP neighbor relationship was unable to form. So what we had to do on both router 1 and router 3 is set the local address for these updates to be correct. On R1 we used the local address of 1.1.1.1, and R3 we used the local address of 3.3.3.3. And now let's go to router 3. If I do a show BGP summary, we can also see from router 3's viewpoint it has the peer of router 1, and it's been up for about 2.5 minutes. We can also do the command show BGP neighbor, and we see that the state is established. And the type, which is the very important part of this lab, as internal. So again, internal BGP neighbor relationship has been formed between R1 and R3. And what we're going to see with internal BGP is very similar to external BGP in that the way you export routes, you have to create a simple routing policy to export routes into BGP. We're going to do this very quickly because it's pretty much the same as internal BGP is that external BGP is. So if you saw my BGP video on external BGP, then this really doesn't have to be explained in a lot of detail, but I'm just going to show you this, how to do this. We're going to create a policy option on R1, set policy options, policy statement. The policy statement name is going to be IBGP. Our term is T1. And then we're going to do from interface loopback 0.1. Then we have our match on the interface. We're going to then accept or allow these routes. Now to apply this, we go under Edit Protocols, BGP, Group IBGP, and we have to apply this export policy under our BGP group. We do this with the command set export, and then the name of our policy statement, in this case was IBGP. We'll go ahead and commit and quit this. If we go to R3 and do a show route, now we can see on router 3 that to get to the one network, we are learning it via two protocols. We're learning it via OSPF, and we're also learning it via BGP. We can see that obviously OSPF has the lower route preference, a route preference of 10, so this is going to be installed into our routing table as the best path. Also for the 11 network, we see that as well. We have the OSPF route, and we also have the BGP route. We can look at this in detail if we do a show route 1.1.1.0 detail, and it gives us exactly a lot of information on the two protocols that we're learning it from. Obviously the asterisk is next to the OSPF learned route because this is the lower route preference. And then we have BGP with the preference of 170. So I just wanted to show you that once you have your internal BGP neighbor relationship up and running, just wanted to show you exactly how to create a simple routing policy to export your routes into your IBGP neighbor relationship. So the last thing we're going to do in this lab is we're going to take a real quick look at BGP authentication. And we're going to set up BGP authentication between R1 and R3. The reason that you would use BGP authentication and why it is used is that for obvious reasons you don't want just anybody setting up a router and being able to peer BGP with you, because that would not be a good scenario. So obviously you want to lock down your BGP neighbor relationships, and the way we're going to do this is with authenticating our BGP peers. Let's go ahead and take a quick look at this. There's a couple ways you can do this on a Juniper router, and the way we're going to do this is we're going to go under Edit Protocols BGP for our group, which is IBGP. If we do the command set space question mark, one of our first options we can see is authentication key and authentication keychain. So you can create keychains within BGP. However, in this lab we're just going to create a simple authentication key. So we'll do the command set authentication key, and then it's going to ask us for the MD5 authentication key. In this case we'll just name it Bowler CBT Labs and hit enter. So we'll go ahead and do a commit and quit. And now if I do a show, let's do the show configuration protocols BGP, we can see that under our BGP configuration on R1 we have an authentication key that we set. Obviously this is going to be scrambled. We can't see this, and it's showing us that this is secret data. So this is obviously information that has been encrypted so that anybody just can't log into the router and see what the authentication keys are. If I do a show BGP summary, we can see that the state is now in connect, and that is not good. Everybody knows, and you should know that with BGP, if it's in anything other than established, then you have big issues. We do a show BGP neighbor, we can also see this information. We have to type as internal and the state as connect. So if it's not established, obviously it's not going to be working correctly. On R3, we can also see this if we do a show route. We have the 1 network and the 11 network being learned via OSPF. However, it's not being learned like before when we looked at our routing table on R3 via BGP anymore. So the way we're going to fix this is if we go to router 3, and we're going to have to put in the same key on router 3's end as well. So we'll do edit protocols BGP group and then IBGP. And then again, the way that we specify authentication is with the set command. We'll do set authentication key. So we'll do set authentication key and then our key name. In this case, when we're peering using authentication keys with BGP, the authentication key has to be the same. So we'll do our authentication key as Bowler CBT Labs and then hit enter. So we'll go ahead and commit and quit. And on R1, if I do a show BGP neighbor, you can see that the state is active still. And now our state is established. Show BGP summary shows that we've been up for about 10 seconds, now 13 seconds. Same thing on R3. If we look at router 3, if I do a show route, we can now see that our routing table is back to normal, to where we have our 1 network and the 11 network learned via our 2 routing protocols, OSPF and BGP. So our BGP neighbor relationship is back up. If we do a show BGP summary, we can see that it has been up for about 40 seconds. Also, show BGP neighbor, we see the state as established. So everything is well. So that's it. Just wanted to wrap up this lab and what we did. We explained the reasons why you would use internal BGP and how you set up BGP. We looked at setting up trace options on R1 and R3, and we also explained the importance of the local address statement under your BGP configuration and using the local address statement correctly. Without the local address statement, we saw that router 1 was trying to peer. It was sending its updates on 12.12.12.1 with the neighbor of 3.3.3.3. However, router 3 was expecting these updates to come from 1.1.1.1. And likewise, router 3 was doing the same thing. It was sending its updates on 23.23.23.3. Router 1 was expecting these on a 3 network, on the 3.3.3.3. So the way we fixed this is we went under R1 and R3 and put in the local address statement. And this is the equivalent to using the iOS command of your neighbor, then your neighbor IP, and then update source, and in this case, loopback 0. Once we did that, our BGP update messages and all messages were being sourced correctly, and our neighbor adjacency came up. And then we looked at injecting routes into BGP. How to do this is the same as external BGP. So I went ahead and did this on R1 and showed you on R3 that the routes were being learned via BGP and OSPF. OSPF had the lower route preference, so obviously OSPF would be the protocol of choice. We then finished our lab with BGP Authentication, which is very easy to set up. We set it up under the, if we look at router 3, if I do a show configuration protocols BGP, we set it up under our group IBGP on both routers with the authentication key command and then our authentication key. So that's it. That's Juniper BGP Lab 2, where we looked at internal BGP and BGP authentication. Thanks for watching, and I hope to see you in the next one.